In this video, I'd like to accomplish 3 goals. First, I'll explain the intuition of the harmonic mean. Second, I'll explain the intuition of why the harmonic mean is less than or equal to the arithmetic mean. And then finally, I'll explain when to use the harmonic mean versus when to use the arithmetic mean. So suppose that you have the following problem. You're asked to create 2 equal weighted portfolio, one weighted by the price and one weighted by the earnings, and then calculate the average price to earnings ratio, PE, of the 2 portfolios. So let's say you have stock A and you have a stock B. Stock A, the price to earnings ratio is 5 to 1. That means that for every $5 that you give into stock A, you get $1 of earnings back. Similarly, for stock B, for every $3 that you put in, you get $1 of earnings back. So let's calculate the PE ratio based off of equal earnings. So if you have equal earnings, what does that mean? That means that for every $1 of earnings that you have for stock A, you have $1 of earnings for stock B. Well, that's convenient because that's what we have right here. So if we have just one stock A and one stock B, then we'll be done. We can just calculate the PE. So let's do that. So it would be 5 over 1 plus 3 over 1. That's equal to 8 over 2, which is equal to 4. Now, another way of writing this, and you'll see in a minute why I'm doing this, is the 5 over 1 is the same as 5 in integer form, plus 3 over 1 is the same as 3. And since we're taking an average, let's put a 1/2 over here. We're taking an average of these two numbers. So that'll give us 4, the same number up here. So same way, same calculation, just different way of writing it. Now the reason why I did it this way is because I wanted to make it explicit that what we're doing right here, we're actually calculating the arithmetic mean. So let's recall the definition or the formula of the arithmetic mean. So that's 1 over n, I equals 1 to n of xi. And n is the number of things that you're calculating. In our case, we have 2 things, so n is equal to 2. And xi is the thing that you're calculating. So x of 1 is 5 over 1, and x of 2 is 3 over 1. Okay, good. So now let's calculate the PE based off of equal prices. Now, we have a problem immediately because the 2 prices are not equal. We have 5 over here, that's the stock price of A, and then we have 3 over here, the stock price of B. Now, we could try to equalize these prices, and equalizing 5 and 3 is the same as asking what's the least common multiple of 5 and 3. Well, that's 15. So let's try to equalize the prices first and then see where that takes us. So we have 5 over 1 times 3 over 3. That's 3 divided by 3, that's just 1, so I'm multiplying this whole expression by 1. Plus 3 over 1 times 5 divided by 5. Okay. And since we're taking an average, let's multiply this whole term by 1/2. So now we have 1/2, 15 over 3, plus 15 over 5. Okay, very good. So the prices are now equalized. The prices are now equalized. We have 15 over here and 15 over here. But the problem we have is we can't add these 2 terms together because the denominators are different. We have 3 and 5. So how can we add these 2 terms together? Well, one way to sidestep this issue is to flip these 2 terms. Flip this guy and flip this guy, and then add them and take the average. So I'll show you what I mean. So you have 1/2, 3 over 15, plus 5 over 15. So let's keep a note that this is a flip that we did, and we'll call this the first flip. So now that we have the denominators the same, now we can add these 2 terms together. So we have 1/2 of 8 over 15 cancel out the 2, so we have 4 over 15. Okay, very good. Now, but remember, because we did this first flip, this is in terms of earnings over price now. But because the question asked us what's the PE of this portfolio, we need to flip this guy again in order to get this to be price to earnings rather than earnings to price. We have to undo the first flip. So if we do that, if we flip it again, we'll have 15 over 4, or that's 3.75. And let's keep a note that we did a second flip. Okay, very good. So what did we do here? This actually is the logic of the harmonic mean. So I'll write down the formula. So let's see here. It's 1 over 1 divided by n, sum I equals 1 to n, 1 divided by xi. Okay. So this can look pretty complicated and confusing, so let's unpack this. First, notice that this term right here, below the bar, below this bar right here, that's pretty similar to the arithmetic mean, except that instead of xi for the arithmetic mean, we have 1 divided by xi. And 1 divided by xi is just the reciprocal. So the bottom part right here, this is saying that take the average of the reciprocal, but then this top part right here, just flip it again. So this corresponds well to what we did up here. This right here, 1 divided by xi, well, that's a flipping. This flip corresponds to this flip right here. And then this guy right here, 1 divided by this whole term, well, that's another flipping. And this corresponds to the second flip that we did up here. So hopefully that gives you some intuition as to what's going on with the harmonic mean. Okay, let's talk about the second question. Intuition of why the harmonic mean is less than or equal to the arithmetic mean. Yes. So we have two means right now. We have the harmonic mean, which is 3.75, and the arithmetic mean, which is 4. This guy is less than this guy. Why is that? Well, take a look back at what we did up here. This is stock A. Let's go up here a little bit further. This guy, 5 over 1, that's from stock A. 3 over 1, that's from stock B. Remember what we did. We flipped it first, and then we took an average. We flipped it, and then we multiplied by 1/2, take the average. So the 5 over 1 became 1 over 5, which is 0.2. And the 3 over 1 became 1 over 3, which is 0.3 repeating. So 5 over 1, it was initially bigger than 3 over 1, but then because we flipped it, it became 0.2, which is smaller than 0.3 repeating. So the harmonic mean, it favors the smaller number. Bigger numbers initially going in has a smaller influence compared to the small numbers. Smaller numbers going into the harmonic mean formula, it has a bigger influence. Whereas the arithmetic mean, we didn't do this. We didn't do the flipping. So the original numbers preserve the amount of influence that they have is preserved when we calculate the average. Now, why does the harmonic mean do this? Well, one of the reasons why it does this is because it wants to control for outliers. So what do I mean by this? Let's say that you have 3 stocks instead of 2. So stock A we know is 5 over 1. Stock B we know is 3 over 1. And let's say that stock C, it's something very unusual compared to these two. Let's say it's 1,000 over 1. Well, if you put these 3 values into the harmonic mean formula, then the 1,000 divided by 1, when you flip it, it's going to be 1 over 1,000. So it's going to have a really tiny impact on the average, on the overall average. Whereas if you calculate the arithmetic mean of these three values, the 1000 divided by 1 will have an unusually large impact on the overall arithmetic mean. And that actually leads us nicely to the final question. Oh, and so that's why the harmonic mean is less than the arithmetic mean. And to see when the harmonic mean is equal to the arithmetic mean, that's a trivial case, which is, think about if the stock A, instead of 5/1, it's 1/1, and stock B, instead of 3/1, it's 1/1. So in that case, the harmonic mean is equal to the arithmetic mean, if you run through the logic or the formula. So let's talk about when to use the harmonic mean versus the arithmetic mean. Well, I give you so this would actually be one of the use cases for using the harmonic mean, when you have some outliers in your data that you want to control for. In this case, the harmonic mean would look pretty reasonable, whereas if you use the arithmetic mean, the stock C will have an unusually large effect on the overall average. The other use cases, the other way that you would know when you would use the harmonic mean versus the arithmetic mean, you would ask yourself, based off of the problem that you're working on, are you trying to equalize the numerator, or are you trying to equalize the denominator? And depending on what you're trying to equalize, then that's the mean that you should be using. If you're trying to equalize the numerator, then you should be using the harmonic mean. This is in the event that you are dealing with ratios. And if you are trying to equalize the denominator, then you should be using the arithmetic mean. But that's also provided that you don't have some significant outliers. So hopefully that gave you some intuition as to what the harmonic mean is, why it's less than or equal to the arithmetic mean, and when to use the harmonic mean versus the arithmetic mean.